shows it. It shows how much time you've been going, but I'm not going to go back and look at the screen.
Let's just try to get half hour. I'm sorry. Yeah, half an hour later.
And I'm still on my first slide.
Yeah. My first day. So access last. This is.
Yeah.
It's one is really tight. Yeah. You had a 10-minute talk.
Yeah.
I promise I will try and go back. I timed myself this now and I did it successfully.
Oh.
And I also kind of stumbled over my work a few times, so hopefully I'll manage to get it to keep it to 20 minutes now.
Yeah, I think I have a 40-minute slot.
Yeah, I think a good idea.
So I'm kind of mute.
Yes. So for 5 minutes, 10 minutes.
Well, look at YouTube on the time.
I will.
That's enough. Well, he just wanted to say certain things. He was going to give it some commentaries. But it was just
So I guess at the end we'll just all come up on stage. I've got it on me. Oh, the...
All right, we'll be starting our third symposium. I really apologize for running out of coffee. I thought that I had told them to have 2 urns and they just had 1. So, but I can guarantee you we'll have enough sausages this time. At least I hope. All right, so let's go with the next symposium.
Switch.
1, 2, 3, testing. Okay, good morning, everyone. Thanks for coming back in, and welcome to today's symposium, which is titled Unconscious Perception, Does It Exist, and What Do We Require, or What Should We Require from the Evidence? This symposium was put together by Axel Clemens and myself, and we'll hear talks from Joel Pearson and Zoltan Dianis as well. So let me start off with basic assumptions that have gone into a lot of work in our field. And those assumptions are that some perceptual and cognitive processes require awareness and others do not. And therefore, in order to understand, if we were to understand the difference, that would further our understanding of the functions and architecture of consciousness itself. Now, in recent years, there's been an explosion of studies on various kinds of unconscious processing, unconscious perception, which raises the question, why now? There's always been a trickle, but in recent years, there's really been a flood. One possible reason is that there is a current intellectual fashion that views unconscious processing as cool. Another is the emergence of easy-to-use and cool techniques for suppressing stimuli from awareness, such as continuous flash suppression, which has been mentioned a lot in the conference already. And many, many phenomena have been demonstrated without awareness. These include perceptual after effects, priming, learning, attention, semantic processing, and most recently, even arithmetical calculation. Which kind of raises the question of what do we need awareness for at all? If we can do all these things without consciousness, without awareness, perhaps the whole concept of awareness, perceptual awareness at least, is kind of epiphenomenal and doesn't actually carry function. What we want to ask is, should we be taking these findings at face value? And there are reasons to doubt this. Many studies don't actually compare conscious and unconscious perception directly, despite the fact that that is the basic motivation for this whole line of research. And there's an emphasis, a large emphasis in the field on what can be done without awareness, but not on what can't. Now, there are reasons for this. One reason is that in order to show what can't be done without awareness, you have to have a null result, and null results are hard to interpret and even harder to publish. Null results are also, almost by definition, uncool. But the problem with that is that it might be leading us to a large file drawer effect, where many failed experiments, and everyone in the field, including myself, has some of those, don't get published. Another issue is that in many cases there seem to be lax criteria for accepting the absence of awareness, and an insufficient effort to rule out explanations that don't invoke unconscious processing before concluding that it has occurred. And this might lead to overblown claims regarding how much unconscious perception goes on in the human brain. So in today's symposium, we have a collection of both supporters and skeptics of unconscious perception. We had a bit of a discussion on the right nomenclature here. We thought we'd use believers and deniers, like in climate change, but we settled on these. What we all agree on is the need for rigor in assessing unawareness. What we hope to have is a good discussion of appropriate criteria and methods for investigating unconscious perception and concluding that it has occurred. But we have absolutely no pretense of having the final word on this. So at the end, we hope there'll be enough time left for some productive discussion both between ourselves and with the audience. So, without further ado, we will move on to, sorry, I'm just going to stop my stopwatch here and restart it because I'm giving the first talk. So my talk is titled, Unconscious Perception is Not a Single Thing. That's one of the titles that I could use. Another title that I didn't go with officially, even though it's more accurate, is Some Things We Need to Talk About, or to think about when investigating unconscious perception. And when I say some things, it means I'll talk about some things that have come up in my own research, but it's not meant to be an exhaustive list. So what I'm going to try and do is focus on critical issues that come up when investigating unconscious perception. And I'm going to be describing several studies, but because I'm going to be using these to make specific points, I'll not actually go into the details of these studies in as much detail as I normally would. So if anything's unclear about any specific study that I mentioned, please feel free to ask me about it afterwards. I also really didn't want this to be the kind of talk or the kind of symposium where we poo-poo other people's work. So I'm going to be taking the perhaps foolish approach of applying the critique to my own work, mostly. What I hope to show is that generally the conclusions from this work survive, but that we can always do better. So the general structure of the talk is I'm first going to talk about the efficacy of suppression methods and why we sometimes might have reason to doubt this efficacy. I'm going to talk about the first way in which unconscious processing is not just one thing by talking about different types of unconscious perception. I'll move on to a second way by talking about the different mechanisms that may underlie different suppression techniques. Okay, so let's start with the efficacy of suppressing stimuli from awareness. So I mentioned these two basic assumptions before. Some processes require awareness, others don't. There's also a technical assumption that goes into a lot of work in this field, and that assumption is that the techniques we employ to suppress stimuli from awareness work and continue to work throughout the time that we employ them. And this assumption is actually not entirely warranted, at least not in all cases. So I'm actually going to start with an example for someone else's work using backward masking. So this is a study that showed large individual differences in the efficacy of backward masking across people. This is a study by Luis Pessoa and colleagues. What they did was they showed people one face that was either emotional or neutral, and it was masked. They showed it briefly, and it was masked by a second neutral face, and they asked people what the emotional expression on the masked face was. And what they showed was that different people had very different abilities to do this. So these are receiver operating characteristics, or ROC curves, from two individual subjects. For those of you who are not familiar with ROC curves, I'm not going to go into them. I'll just say that performance on the diagonal line is chance performance. Anything that deviates from the diagonal line is above chance performance. What we can see here is one subject who was at chance for sort of the standard display durations for masking of 17 and 33 milliseconds. But here there was another person who actually did quite well at 33 milliseconds and was slightly but reliably above chance at 17 milliseconds, which is just one frame at 60 hertz refresh rate. So that's individual differences, which means we can't just assume masking works equally for everyone. A second aspect is something that I've come across at conferences quite a lot. So anyone who does work on CFS will be familiar with how you go to conferences and you meet people who say, oh, I can't do CFS on myself anymore. I've had too much exposure with it. It doesn't work on me. And there's actually been a couple of publications that support the idea that CFS might weaken over time. In my lab, we recently completed a study where we looked to see whether people can learn to overcome CFS with time. Again, I won't go into the details, but what we did was show people continuous flash suppression stimulus where they had to make an orientation judgment on a suppressed Gabor patch, whether it was tilted clockwise or counterclockwise from a cardinal orientation, in this case horizontal. We used 8 different contrasts to span the possible contrast range and see what contrast would be needed for breakthrough. And importantly, we brought people back for 5 days. It was actually longer, but I'll focus on these 5 days. And we had them do 640 trials a day. What we found was very simple. So on the horizontal axis here, we have arbitrarily labeled contrasts from low to high, and performance on the vertical axis. And we can see that on the first day, people were at chance for all contrasts, but as the days went by, they got better. And as you'd expect, they got better more for the higher contrasts. Importantly, contrasts 3 and 4 and 5 are in the range that is sort of 15 to 25% contrast, which is commonly used in CFS studies, meaning that people can learn to overcome CFS. Another thing we found here was a large range of individual differences again. So we did within subject statistical analysis for each subject, and we found that the effect was due to the fact that some people were learners, while other people simply didn't improve throughout the experiment. So we had learners, non-learners, and I should mention we also had 2 subjects who were just completely immune to continuous flash suppression right from the start. We did a very similar experiment with masking and got basically the same results. So to conclude this particular point, both CFS and masking weaken over time. There are large individual differences in both the suppression and the change over time. And this has practical implications for experiments that we run. We can't assume that both CFS and masking will continue to work indefinitely. We should verify that they continue to work. Ideally, we should do so on every trial, but this isn't always feasible. And in cases where it's not feasible, we should do so both before and after testing, or even just after, but not just before, as is quite commonly done. OK, so that's the technical bit. Let me move on to a slightly more conceptual, the larger, more conceptual bit of the talk, where I talk about how unconscious processing is not a single thing. So for this, I'm going to use this following framework, which divides reports and performance into two kinds. We can have subjective report, where people are asked if they did or didn't see the stimulus, and objective task performance, where people can either make some perceptual judgment of a stimulus or not. So if they see the stimulus consciously and can do a task, we just call it conscious awareness, which raises the question of how much awareness there is, but that's not our focus here. If they say they saw something but can't do any task on it, we might call them delusional. A good example of this is Anton syndrome, where people who are blind claim they're not. What we really want to focus on now is these two rubrics. When people say they didn't see something but can still perform a task above chance, we call this subjective unawareness. Classic examples of this are blind sight and some cases of performance in normal observers with masking. This, of course, raises the issue of maybe people are just adopting a really strict criterion for reporting awareness under conditions of suppression. And I'll talk about how we can address this using confidence ratings. The other type of unconscious perception is objective unawareness, where people both report not seeing a stimulus and can't perform a task above chance, but where we have either some behavioral indication that perceptual processing had taken place, such as priming or after effects, or some physiological evidence, such as skin conductors responses or neuroimaging fMRI bulge responses. So I'll start by talking about subjective unawareness, and I want to talk about an example of using confidence ratings to support the idea of unconscious processing. This is a trial structure from a study I was involved in a few years ago. What we did in this trial was, study was show a word on each trial. It was both forward and backward masked. And what the task was for subjects to simply report whether the word was emotional or not. In this case, for example, the word is hurt. I don't know if you can see it, which would elicit the answer, yes, this is emotional. And we wanted to test the emotionality, the valence detection for both positive and negative words, and test sensitivity to them. So we had in different blocks both positive and neutral words, and in other blocks negative and neutral words. We also got a confidence rating or visibility rating at the end of every such trial. I should say we presented these words under two conditions. One, where the presentation was brief but high luminance and people saw the words, and one where it was low luminance and therefore masked to the point that people were not aware of it. So what we found was what we call the negative word advantage, which wasn't terribly surprising. It's what we predicted. The idea was that people had higher sensitivity for negative words than for positive words. This was when the words were visible. When the words were not visible, when the luminance of the words was low, the effect was preserved. People obviously were much worse at the task, but they could still detect the valence of the word above chance for negative words, but not for positive words. Now, of course, this raises the question of how could we be sure that the words were indeed subliminal? Just because we lowered the luminance and couldn't see them ourselves doesn't necessarily mean our subjects couldn't. Maybe masking wasn't effective. There was some awareness of the words after all, even in this condition. So one thing we did was we compared confidence ratings, average confidence ratings for the positive and negative words. And what we found was that overall confidence was very low, very close to the minimal level of 1 on the 1 to 5 scale. There was, however, a tiny but statistically significant difference favoring negative words. So what can we do about that? Well, one thing we did was use a very common approach of saying, well, maybe the effect was due to those few trials where people had above guessing confidence. And we looked only at those trials, therefore, where people reported complete guessing, a confidence rating of 1. And the effect was preserved under those conditions. Another thing you can do in such a case is compare confidence ratings on correct and incorrect responses. And when we did that, when we compared both for negative and positive words, we found, I didn't even put the numbers on here because there really wasn't any difference. People were equally confident when they made the right response versus when they made the incorrect response. And you'd expect if there was some awareness, there would be, on average, higher confidence when they were right. So that's subjective unawareness. And I'll move on to an example of objective unawareness. And this is a study that I actually presented at ASSC in Kyoto 3 years ago, and since then it's been published. And it's a study where we investigated classical fear conditioning and wanted to see whether it could occur even in the absence of awareness of the stimuli being conditioned. What we did was we used continuous flash suppression to show one of two faces on each trial. One of the faces was occasionally paired with a shock. The other one never was. There was one group that ran under these conditions and another group that was aware that had the same procedure but without continuous flash suppression. And of course, to verify unawareness, we followed up each presentation with an objective measure. Here we asked people to simply tell us which of the two faces they had seen. One was always male, one was male, one was female, so we simply asked them which gender had been shown. This, of course, is insufficient on its own, as we know from cases of blindsight where people can make such binary distinctions above chance despite claiming to be guessing. So we also had a subjective measure asking people how sure they are of the response they just made. And that's insufficient on its own because of criterion issues, as we already discussed. The logic here was that if we found objective performance, that is, objective unawareness, chance performance, plus subjective unawareness, low confidence ratings, but differential conditioning, differential skin conductance responses showing some physiological conditioning, then and only then would we conclude that unconscious conditioning had occurred. So what we found, first of all, for the sanity check was that the awareness manipulation worked. So the unaware group was at chance, slightly below chance, in fact, for gender detection, and they had very, very low average confidence and no difference between correct and incorrect responses. As for the results themselves, skin conductance responses are pretty noisy, so we collapsed them across the first and second half of the experiment. For the aware group, we found a standard response pattern of not much going on in the first half of the experiment, and by the second half of the experiment, there was a reliable difference. For the unconscious group, we also found learning, but it had the opposite pattern where there was learning early on in the experiment rather rapidly, and it had disappeared by the second half of the experiment. So there was a difference between the two halves in both groups, but in opposite directions. And if we just look at the stage in which learning had occurred, there was a numerical difference, but at least for the statistical power we had, there was no statistically significant difference between them. So what we have here is a case of a qualitative difference between conscious and unconscious processing. In this case, the qualitative difference is in the temporal profile of development over time, which makes it harder to explain in terms of maybe just a reduction of what's going on anyway with awareness. But it does raise the question of whether we were assessing consciousness properly. Were we asking people the right questions? So let's think back. When we did this word valence study, we asked people whether the word was emotional or not. Now, we knew from piloting that people couldn't identify the word. They couldn't tell us what the word was, but we showed in the experiment that they could extract valence from it. So the task you give people matters in how well they can actually indicate what was going on in the stimulus. In the second study, we could ask what sort of task was our gender identification. We showed people two faces, male or female. That raises the question of maybe this gender identification was kind of similar to word identification. Maybe subjects couldn't do it, but could still somehow distinguish the faces. So David Shanks, for example, asked me whether it was possible that there was some physical characteristic of the faces, and I added a really blotchy one here just to make the point, even though it didn't actually appear on the real face, that wouldn't enable people to pick up the gender, but would enable them to reliably distinguish the faces. And if that were the case, then we missed perfectly conscious learning by asking the wrong question. So this comes down to, could subjects be aware of the face but still at chance on gender identification? I think it's possible, but I think it's unlikely in this particular case. Let's think about what we need when we choose a task for this kind of assessment. We want something that will allow for a quick response. In most cases, we prefer binary responses, although that's not absolutely essential. And we want to use existing categories and distinctions so that people don't have to learn new ones specifically for our experiment. It just so happens that gender recognition is extremely fast and efficient. People can do it for brief or degraded presentations. They can do it just for textures of faces or outlines. They can do it with isolated face parts. And that led us to reason that any conscious exposure would most likely allow for gender identification. Now, that said, next time I run an experiment like this, or if I were to run this experiment today, instead of asking which face did you see, the male or the female, I'd probably show something like this and just say, which of these two faces was it? And I wouldn't put it through a filter of trying to extract any specific information from the face. Now, another possibility that's raised sometimes is maybe the task should directly address the variable of interest rather than asking about the stimulus. So in other words, instead of asking which of these two faces you saw after the presentation, maybe during the presentation we should be asking, do you expect to get a shock now, or are you afraid? So that's a possibility, and some people think that's the right way to do things. And I think it's possible, but I don't think it would be any better. So it substitutes asking the subjects about the stimulus for asking them about their internal state. Am I afraid right now? It can be answered by observing one's internal state. And some people are very good at this kind of interoceptive awareness, monitoring their own heart rate, etc. And that could be a very interesting way to mediate the effect, but it could still happen without any direct awareness of the stimulus. The last point I want to make about this has to do with the very common practice of truncating the data. That is, removing trials in which there was above guessing subjective awareness in order to look at performance. And I showed before that I did exactly this with the word study. Now, let's assume for a minute that these two concepts, perceptual processing and perceptual awareness, are actually one and the same, that there is really no difference between them by definition. It's a single underlying construct in the brain. However, we don't have any direct access to it. What we have is ways of measuring it. And we have objective measures for processing and various measures of confidence, visibility, perceptual awareness scales for the awareness. And if we want to measure objective stuff, then we will consider no processing when there's chance performance or zero on some tasks. For confidence, we will expect subjective invisibility of the stimuli or complete or total reports of guessing. Now, in order to claim unconscious processing, what we want is zero or near zero confidence accompanied by better than zero or better than chance performance. Now, let's assume for a minute that because these two underlying constructs are actually one and the same, that when you have performance on a task that is above chance, what you have is both awareness and performance, and they are exactly, they correspond to each other exactly because it is a single underlying construct. However, when we produce responses, we always have noise that goes into this response production, and this noise will be independent because these, or at least there will always be an independent component that goes into these productions of different responses. Now, what this means is that on any given trial, we might have noise that goes into the confidence report, and it will be uncorrelated with the noise that goes into the perceptual performance, which means that if we now apply some criterion to remove high confidence or high visibility trials, we can remove those trials from the performance. We will get our chance level or near invisible average responsive confidence. And if we remove those trials from task performance, we might still get above chance performance, but it will be a complete artifact of the way that we truncated the data. Is that logic kind of clear? I hope it is. So the same logic applies when excluding entire subjects rather than individual trials. It also applies when we use various physiological measures rather than task performance. And it applies most strongly in the common practice of using threshold stimuli, where you look at the difference between trials when the stimulus was seen versus when it was not seen, because that's when the noise of the subjective response is highest. It doesn't form a concern when objective performance is at chance and there's consistently low confidence. In such cases, if the effects were still due to the occasional trial where there was some awareness, you'd expect to see some systematic effect on confidence. It would be higher on correct responses. And if we still claim that this could still happen with awareness, that implies that we must invoke a concept of awareness that has an unclear construct validity, because it implies that that awareness is not does not enable us to do a task or confer any ability to report the stimulus. So I could agree that maybe an argument could be formed for that, but if that were the case, it would be a very different kind of awareness from what we normally talk about. And to paraphrase a recent nomenclature by Scott Aronson, I suggest we add a subscript in such a case to that particular concept of awareness. So I'm nearly out of time, so I'll run through the final point here rather briefly. There's a second way in which unconscious processing is not a single thing, and that is what happens when we have different effects for different suppression techniques. So here's a famous study that was the first to report breakthrough CFS. Yang, Zold, and Blake reported that when they showed a face and gradually increased its contrast under conditions of continuous fast suppression and measured how long it took for the face to break through into awareness, they found that it broke through more quickly when the face was emotional than when it was not. Now, the logic here is that the processes that determine breakthrough occur prior to awareness, therefore indicating more unconscious processing of emotional, or better unconscious processing of emotional faces. In my lab, we recently ran an experiment doing an analog of that with crowding, which is a different way of suppressing awareness of a stimulus. So people were asked to make a discrimination on the face in the center here that was flanked by other faces. And we measured how big the distance between the flankers and the stimulus has to be for the face to break through, for people to be able to see it. So there's the same logic here. It's just a spatial version of the same idea. And what we found, so there was an attentional manipulation as well that I won't go into for lack of time, but I want you to focus on the blue and red lines here. Fearful stimuli, fearful faces needed a larger distance in order to break through into awareness, which is the opposite effect from the effect that was found in timing and CFS. So we can no longer just say something like emotional faces have better access to awareness, or emotional faces are processed better without awareness, simply because different techniques might lead to completely opposite results. I should stress that this is just one experiment. This is very much work in progress, but I want to give the idea through this example. Coincidentally, a paper last month in Frontiers from Peter Tse's lab showed the same thing with neuroimaging. Basically, different types of suppression have different underlying neural mechanisms, but I don't have time to go into that. I just want to get to the conclusions. We have a tendency to make a dichotomy, conscious versus unconscious processing, or conscious versus unconscious perception. I think that's an oversimplification. Different suppression methods may have different underlying mechanisms, and if we really want to understand perception, and if we really want unconscious perception to inform our understanding of consciousness, then we have to focus on understanding these underlying mechanisms rather than just using a generic label of unconscious. Personally, I believe that qualitative difference between conscious and unconscious perception hold the largest promise towards understanding these processes. And that's it. Thank you. So I think I have 2 minutes for questions.
Just quick question. You mentioned the need of specifying the effects for different kinds of techniques and what we can infer from conscious and unconscious stimulus. So I think in this case it's important to say what we cannot do with non-conscious stimulus. And you mentioned the problem of replicability and of the negative results. So how do you think we can approach this in the sense that if we need to get the full space of possibilities, this is somehow out of the range of one lab or some small groups?
That's a very good point.
How would you address this problem?
Can you hear me? I think microphone's gone off, but you still hear me? Okay, so I think it's an excellent question. I didn't actually talk about replicability so much, but I think replicability is a good point. I do think it's important for null results not to go over file at all. And there is so talk in just a few minutes. So, yeah. Any other questions? If there's a really, really quick one? Okay, in that case, let's hear from Joel. Thank you very much.
Is there a mic there?
It doesn't seem to be working, but there's 1, 2, 3. No, must be out of battery or something. Do you want to stick back here? Yeah, it's out of battery. If anyone in the organizing, amongst the organizers could arrange for a battery replacement or a different microphone, that'd be great. Feel free to start. We'll just give you a microphone when it's ready.
Well, I guess I can start here and move over.
Yeah.
So thank you, David and Axel, for organizing the symposium. Thanks for inviting me. My talk's going to be a bit more data-driven than the other talks. I'm going to be giving a somewhat a highlights package from 3 different groups of studies. So, yep, that's on. Excellent. Thank you. So, let's start off by talking about decision-making. So what do we mean by decision-making and how can we study it in the lab? So very, very quickly, something like a deliberate process to come up with a categorical decision, normally, let's say, out of 2 different options. And we can think of the analogy of a judge or a jury weighing up evidence over some time period and then coming to a verdict. So how can we study decision-making like this in the lab? Well, we can use real-world situations. We can study things like which house do I want to buy, which car do I want to buy, do I want to drink Coke or Pepsi or coffee or tea, or these kind of real-world scenarios. Or we can use sensory stimuli, and there's a number of good reasons we might want to do that. Things like we can control all the variables. We know where in the brain those variables are processed and things like that. It gives us a lot more what we could call scientific traction to probe the mechanisms involved. So why is sensory visual stimuli, I'm going to be talking about, so sensory noisy dot-like stimuli, why do we use those to study decision-making? Well, there's good evidence that in non-sensory parts of the brain, areas like LIP, we see accumulating or neural activity which looks like evidence is accumulating. And this sort of pattern as a function of the amount of information in the stimulus. And this is a different kind of pattern to that we see in area MT at the bottom there. So it seems like, and this data fits all the modeling data really well, so it does seem like we can use these sensory visual, these noisy visual stimuli to study decision making. So we were wondering, can we use these sensory stimuli to study decision making without awareness, or how information might be accumulated without awareness? So the kind of stimuli we're going to use, here's an example here. So we're going to have the little grey dots. That's our decisional stimulus. So the dots can be moving left or right. They can be moving, say, 100% left or right, or 1 or 2%. The lower the percent, the coherent signal, the much harder that task is. That's going to be in one eye. And in the other eye, we're going to have these yellow dots spinning really, really quickly. And that's going to be suppressing our signal dots. So the subject doing the experiment is just going to see these yellow dots. Okay? And because we have the difference in color, if they ever see a gray dot breaking through suppression, they can hit the space bar and that trial will stop. So in all the experiments I'm going to be talking about, awareness is always being monitored on every trial at every moment, if you like. So here's how we're actually going to run the experiment. We're going to have the unconscious part at the beginning here, and it's going to be suppressed by the yellow stimulus. So people are not going to see that. They're going to see the spinning yellow dots. Then after that, we are going to have a visual stimulus. So that is a decisional stimulus. The dots are going left or right. And the subject just has to look at that and say, the dots are going left or right, okay? If they see any of the grey dots breaking through the yellow dots, they have to hit the spacebar and stop that trial. So they're making the decision based on the visual part, the second part, the grey dots in this stimulus. And we can compare that to something that should look almost the same, or should look the same to the subject, but the suppressed signal here is completely random. There's no left or right information, or almost no left or right information. But to the subject, that should look almost the same. They should see the yellow swirling dots, followed by a clear directional stimulus. So then we can do something like this. We can plot accuracy versus the coherence of that motion stimulus. And here I'm showing you data for the random conditions. That's when there's no clear signal information in that suppressed stimulus. And we can compare that to the coherent condition, or coherent trials, where there is information, and straight away you'll see there's a boost in accuracy there. So it seems that suppressed directional information is somehow boosting accuracy. The question is, how is it boosting accuracy? So there's been quite a few demonstrations of priming and perceptual priming, and first we want to see if this was simply perceptual priming. So this suppressed signal, directional signal, might be, rather than being accumulated in a decision kind of way, it might simply be changing the way people are processing or seeing the subsequent visible stimulus. So what do? We flip the order. So now we have the visible part first, followed by the suppressed stimulus. Okay, so people are still doing the same task. They're saying left or right. They just see the signal dots first, followed by the noisy yellow dots spinning in a circle. And we're doing the same random and coherent conditions. So here again is the random condition and the coherent condition. Okay, so again we see this boost in accuracy. So the order doesn't seem to matter. So that seems to rule out things like motion priming as an explanation for this effect. So the order doesn't seem to matter. So what happens if we remove that visible part of the stimulus? So we either had a visible part before or after. So we just take that away and just have the suppressed stimulus. Or I should say, rather than removing the whole stimulus, we remove the signal. So now we have a visible part. Still, we have visible grey dots. So people still are doing the same task. Otherwise, they wouldn't know what they're making the decision based on. But there's no coherent signal that's visible. So they see the yellow, then they see crazy dots moving all over the place. And when we do that, here's data from 8 subjects, the very small error bars. People are basically at chance. So even though the suppressed information is the same as before, the conscious bit, the visible bit, is chaotic, or it hasn't got the directional information. So people are not getting that same boost, or it doesn't look like people are getting that same boost from the unconscious information. So we can also probe confidence in the same way, same kind of task. They answer left or right. We follow that by a confidence rating, 1, 2, 3, or 4. And then we can do things like look at an ROC curve, and we don't see much of a difference, again, between that random and the coherent condition. We can just look at the actual confidence ratings. I don't know if it's big enough to see, but there's no difference there. But we still replicate that same effect. In the coherent condition, people are doing better. But it does not seem to be boosting their confidence. So one of the hallmarks of these decision-making paradigms is that the longer the stimulus is on the screen for, the better people do. And that's kind of simple, right? Because they're accumulating more information over time, or more information for longer durations. So we wondered if we just showed that suppressed period for longer durations, whether people would be doing better. So this paradigm is the same as before, but we're just changing the duration of the suppressed bit, not the visible bit. And when we do that, we see a significant sort of monotonic relationship just in the coherent condition, not in the random condition. So when that suppressed period is longer, people are doing better. So it looks like they might be accumulating more of this directional decision information. So now coming to things that are more in line with the flavor of this symposium. So controls for awareness. So what kinds of things do we do? So one potential concern is that I said we told the subjects if they see a grey dot breaking through suppression, hit the spacebar, we get rid of that trial. But what happens if the grey dot broke right at the end of that period? Subjects may get confused between a grey dot breaking suppression and the actual visible stimulus, which has grey dots also. So here, we made the visible stimulus yellow as well. So they see yellow swirling and then yellow directional dots. Otherwise, the experiment's the same. And here, we can say if you ever see any grey dots, hit the spacebar, and we stop that trial. Okay? And we throw in catch trials. So why do we throw in catch trials? Well, we want to know that my criteria is similar to your criteria in how we're defining a break in suppression. So the kind of catch trials we do, we force grey dots to break suppression. And when we do that, we replicate the original data, which suggests that, well, thus far, that what might be happening is that this directional information is being accumulated without awareness. Okay, it doesn't seem to matter if the stimulus is before or after the visual stimulus. It seems to boost accuracy, but not confidence. And we get the nice duration effect. So now I want to move on. We're still going to be talking about decisional kinds of tasks and information, but I want to talk a little bit about emotional information. So what happens if we start throwing in emotional information, why people are doing these kind of noisy sensory decision-making tasks? So now, what we're going to do, we're going to have this is what people are kind of seeing on the screen. They might see fixation in the middle. They're having the same sort of noisy dot stimuli on one side, and then we're going to show IAPS pictures or emotional pictures, positive or negative, on the other side. And we can set this up so within each subject, every direction is linked with a particular valence. So in this case, rightward might be linked with negative and leftward with positive. And then what we can do, we can use continuous flash suppression to suppress the emotional images. Okay? So everyone knows what CFS is now. So what people are going to see is something like this. They're going to have fixation, these moving dots, and CFS here. And their task is simply, on a brief 400 millisecond display, to say which direction those moving dots are going in. And we can throw in control conditions where we do something called phase scrambling those images. That's a way just to shuffle up the spatial phases in those images, so we keep the color, contrast, and other low-level perceptual characteristics the same, but taking away the overall information in the image. So people are reporting, first here's the accuracy data. So straight away you'll see that in the emotional trials where the directional task is accompanied by intact emotional information, people are getting a boost in accuracy, particularly for the lower motion coherences. Okay? So the coherences on the x-axis there. When we scramble those exact same images, people aren't doing as well. That's the red data there. So we can also get people to rate their confidence after they do that task. And we see a boost in confidence as well. So this is from the same data. Again, trials where people are doing better in accuracy, they're also doing better in terms of confidence, or they're higher in confidence. And they're reacting faster. Their reaction times are a bit faster as well. So we've replicated this effect many times now. I haven't got time to go into all the other kinds of experiments we've been doing. And we show this with subjects who are naive to the purpose, the idea behind the experiment. We always include catch trials, so we force those images to break suppression, so we can test the criteria of these subjects in their reporting of the normal trials. We know if an image is going to break suppression, we can trust their reporting. And if subjects aren't reporting those catch trials accurately, we don't use their data. And the data I was showing you, on average, it's about 97% accuracy in reporting those catch trials. And of course, we only use trials in which suppression is not broken. We throw out trials when suppression breaks. And we also, after we finish the main experiment, we do an objective, separate awareness test. And we can show that people are at chance at that. So it seems from those two sort of groups of experiments that what we might call unconscious, non-emotional information, the directional dot information, can boost accuracy, but doesn't seem to be boosting confidence. Whereas the unconscious emotional information seems to be boosting accuracy and confidence. And Galang, one of my students, is going to be talking about this a little bit more this afternoon. And if you want to hear why we might think this paradigm and along with some other experiments might be a nice way to sort of probe what you might want to call something like intuition, that could be controversial, go along to his talk. So then the third thing I want to talk a little bit about is motion-induced blindness. I'm presuming everyone's pretty familiar with this. Anyone not seen motion-induced blindness? That's good. So at some point, if you keep looking at this, you'll see the yellow dots disappear. So motion-induced blindness, MIB, has been used as a popular tool to study visual awareness. We all know that. Largely because it can help us dissociate low-level stimulation and sort of top-down or just visual awareness. So we were wondering what would happen if we removed awareness from motion-induced blindness. Could we suppress the whole process of motion-induced blindness outside of awareness? So we pitted two different kinds of bistable or awareness-like stimuli against each other. So we're going to use continuous flash suppression to suppress the whole MIB stimulus and sort of see if we can probe to see if the mechanisms of that are still continuing without awareness. So let me unpack this a little bit. It's kind of a mix between a model and a timeline. So first of all, we have time going across from left to right. Then that sort of blurry gray line is what we might want to call an awareness threshold. And then the little colored lines are each single trials of awareness going up and down of a yellow dot in motion-induced blindness. And that response cue, that dashed line, the vertical line, is when we might ask subjects, now, hit the space bar as soon as you see the yellow dot. So if that line is up, they're going to hit the button straight away. If it's down, if it's below that awareness threshold, they're not going to hit the button straight away. They have to wait a moment or two until that yellow dot comes back into awareness. Okay, so that's the kind of half timeline, half model. So then we throw in CFS, and let's just say it looks something like this. And we're pushing all those trials, all those sequences down below the awareness threshold. So one idea might be that when you do that, they all go flat. They're all truncated, squashed together like that. So there's no MIB vacillations or dynamics going on anymore. Then we switch the CFS off, and people have to do the same thing, hit the space bar when they see the yellow dot. As the CFS switches off, in all those trials, the yellow dot becomes conscious immediately, so you get all the same reaction times. Or perhaps MIB continues without awareness. So again, we're adding the CFS here, and it's suppressing all these trials below that blurry gray line, the awareness threshold, but they're still going up and down. Okay? Then when we take the CFS off, doing the same thing, people have to hit the space bar when they see the yellow dot. While all those the MIB sequences move upwards, some of them are up and some of them are down. So you're going to get the same distribution or similar distribution. Sometimes people are going to hit the button straight away. Sometimes they're going to have to wait for the yellow dot to come back into awareness. So here's the actual timeline. This is basically the same as I just described. We have 5-second periods of looking at motion-induced blindness. And then we play a tone, and people have to hit the button when they see the yellow dot. So we can compare that to a control condition. We call that the off-on control condition, because the yellow dot is not there during those 5 seconds, and we switch it on at the tone. So the idea with this control condition is that during that 5 seconds, because the yellow dot's not there, MIB can't be happening in the same way. So when the yellow dot is physically switched on the screen, it should be apparent immediately. So here's the sort of mean reaction times for what I just described. So in the dark red, you have the normal motion-induced blindness, and people are responding overall close to 1 second. Okay? In that off-on control, you have much shorter reaction times. So then we can add the CFS in to the other eye. So we're suppressing the yellow dot and the rotating, the little blue crosses. Then we take the CFS off, and people have to hit the button as soon as they see the yellow dot. Simple. When we do that, we see something similar. The mean reaction times in the dark blue for the main condition suggests that overall the reaction times are similar whether CFS is there or not. And we get the nice significant difference between that and the control condition. What we can also do is, instead of CFS, we can have a difficult letter detection task there at fixation, just to pull people's attention away. So we can do that, everything else being the same. We see a significant difference, again, between those two conditions. Then we can use CFS and this letter detection task, so we're taking away awareness and attention at the same time, and we still just get a difference between those two conditions. Or another way to look at the data might be something like this, where the vertical, you have the median reaction times for the test conditions, and on the x-axis, that control off-on condition. And simply to note that all the lighter dots are individual subjects, and they're all up above that diagonal line. So people are getting, each subject, almost each subject is getting, having longer reaction times for our, what we're calling test condition. And we also ran a bunch of different controls that I don't have time to talk about, but looking at things like, using static motion-induced blindness and things to rule out lingering effects of continuous flash suppression. So this is just the highlights package, so there's lots of other controls that I didn't get to talk about, but so far, what's occurring without awareness? So we have some evidence for accumulation of noisy directional information that we might want to call decision-making, emotional information integrated with a categorically different task, right? So we have the motion over here, seemingly maybe being integrated with these noisy dots over here, and that's unconscious. And that's boosting accuracy, confidence, and making people respond a little faster. And some evidence that motion-induced blindness, a bistable phenomenon in itself, might be occurring without awareness. And out of the things I've just talked about, what might require awareness? Well, the confidence boost from the directional dot stimuli. And just to really quickly cap up again, we always use moment-to-moment measures of awareness, catch trials in all these experiments, and a post-experiment objective measure of awareness. And just to thank Alia and Galang, my two students, Kevin and Duye, are collaborators with the MIB stuff, and thank you guys for listening. Any time for questions, or? Yep, okay. A few minutes for questions.
Hi. So you mentioned the addition of catch trials.
Oh, there, sorry.
And,
yeah.
And this might be a good idea, but I was also wondering if it could be a source of like an artifactual effect, like if it could induce the effect that you call unconscious simply by conscious stimulus response mapping. If subjects see the stimulus once in a while, this could, lead to a stimulus response mapping, which is actually conscious.
This is for the middle sort of experiment.
Yeah, the emotional stimuli thing. Yeah.
So you're talking about something that might be learning that might be conscious. Is that what we're kind of getting at?
Exactly.
Mapping between the valence and the direction.
Yeah.
Yeah. So I didn't want to make any claims about learning being unconscious because this data doesn't support that. But even if occasionally, let's say, you get a few suppression breaks, and that could lead to, if you like, the learning being unconscious, let's just say, then I don't think, while the learning might require consciousness, I think the information is still boosting accuracy and confidence without awareness. So I think the process or mechanism we're interested in terms of decision-making and how the emotional information is being used, I'm happy calling that fairly unconscious, but not the learning. Is that get at what you are? Yeah.
You ready?
Up the top there.
I wonder whether you checked the switch rate of your MIB subjects. Olivia and I showed that MIB is a rhythmic phenomenon, and the switch rate varies over almost an order of magnitude in a normal human population. So you would expect that since you used a temporal paradigm to look at MIB, that there'd be an effect of the switch rate of the subject.
We didn't have a thorough look at the individual differences, no. That's what you look at? Yeah, the individual differences. No, we haven't looked at that yet. So time for one more question.
Yeah, so thank you very much for the very exciting talk. I just had one very small question, actually, but maybe you can clarify that.
Sure.
About the emotional manipulation that you do. So you show that there's a boost related to the emotional images, but that's compared to a simple neutral condition where you do face crumbling.
Yep.
So my question is, how do you know this is emotional? It might be just like
All right.
when you see an object, you just have a boost. Or,
Yeah, I didn't have time.
And just
Sorry.
to finish on this, maybe a better condition would be to compare that to, say, an inverted image or an upside-down image. Yeah.
Yeah, so we've run all the exact same experiments with different types of categories of images. So rather than using emotion, positive, negative, or emotional images, we can use inanimate and inanimate images or different categories like that. And when we compare those sort of categories to the scrambled, there's no difference in any of those data. So if that's what you're getting at, whether just a category of picture information might contribute to these decisions, at least it doesn't in these short 400 millisecond displays. It may if it was much longer, right? Maybe the emotional information is just stronger or something like that. Yeah. That's all. Thank you.
All right. Yeah, this is working. So we, users and consumers of the techniques of statistical inference, have had a problem in knowing when to say no. By that I mean we've had a problem in knowing when we can say and when we can't say. There's no effect, there's no relation, people are at chance, and so on. And I think this problem is a deep part of the credibility and reproducibility crisis that many fields are having. So it's a very general problem, and the solution I'm talking about is a very general solution. And the problem is in some ways life and death. For example, people have concluded that a drug has had no side effects, or not a particular side effect, for example, not an increase in suicide rate, because it was a non-significant increase in suicide rate. And that sort of decision has demonstrably cost lives. But what I'd like to do is to talk about it in the context of conscious and unconscious. And in that context, this is a sort of schema for how we infer that there is unconscious perception, as I put it here, or in general, unconscious knowledge, say, in implicit learning context. We say there was some priming, there was some perception going on, but because some measure of conscious perception was non-significant, therefore there was no conscious perception. Now, you all know that that's a problem. And the problem is that when you get a non-significant effect, that doesn't make a distinction that we want to make. That doesn't distinguish having support for the null hypothesis, in other words, the hypothesis of no difference. And just having insensitive data, in other words, we're in no position to draw any conclusion whatsoever. So what we'd like to do is to make a three-way distinction. So H0 is, say, the hypothesis of no difference, no effect, no relation. Call H1 the hypothesis, there is a difference, there is an effect, and so on. There's roughly 3 states of affairs in terms of what our data are telling us. The data could be saying there's support for H0, could be saying there's support for H1, or they could be saying nothing at all, the evidence is just insufficient. You haven't run enough subjects, you didn't have enough trials, there's too much noise, and so on. The trouble with p-values is they make a two-way distinction. So the 2 things on the left there are not distinguished in any way by p-values. You lump them together and contrast that with evidence for H1. So if you get a significant result, okay, you have some evidence, typically, for there being a difference relationship, and so on. But if you have a non-significant result, then you in no way make a distinction, no matter what the p-value, between having no evidence at all for anything and having support for H0. And that's true no matter what your p-value. So you can't say, look, my p-value is 0.9, therefore this is good evidence for the null hypothesis. Because no distinction is made between those 2 things on the left-hand side. So what can we do? Well, in a way, you all know what I've just told you. But because there hasn't been a solution that people have known about, you feel something different in your bones, and I still do, despite going around the world for years telling people all these things. Nonetheless, when I get a non-significant result and a high p-value, I feel the temptation to say, look, there's no effect there. I feel that temptation to slip from the performing non-significantly above chance to saying the subjects were at chance. It's a simple transition that sounds all right, but is completely misleading. I took a recent issue of Journal of Experimental Psychology General, and in 100% of the articles of that issue, bar one that used some Bayesian techniques, the authors used a non-significant result to, simply on the basis that it was non-significant, to assert a null hypothesis, which is completely groundless. I mean, there's no basis for doing that. So I think this sort of cuts 2 ways. If your key result is non-significant, people say, oh, no, you can't publish that. I don't know what to do with that. You get a file draw problem. But if you have a key result that's significant, people feel completely free, utterly uninhibited, in using null results to assert, non-significant results to assert null hypotheses. So the solution I want to talk about is the Bayes factor. This has been around for many decades, since the 30s, when it was developed by Harold Jeffreys and Alan Turing. You can think of this as a number, called a B, that tells you how much more likely the data are on one hypothesis versus another. So it's comparing 2 models or 2 hypotheses. It's completely symmetric with respect to those 2 models. P-value is asymmetric. So it gives you the relative strength of evidence for the one model rather than the other. So it tells you how much more likely the data are on one model rather than the other. So it's saying that the strength of evidence for one model depends on how strongly that model predicted the data. So that means the Bayes value of 1 means the data is just as well predicted, just as well expected on either model. So the data do not distinguish the models. They do not distinguish, say, the null hypothesis from the alternative. And at least in the way I've put it, I think, on my online web calculator, because I think that's most intuitive, if the Bayes factor is greater than 1, then the data are better predicted by H1, by the alternative, by your theory, if you like, rather than the null hypothesis. So the more the Bayes factor is above 1, the stronger is the evidence for H1 rather than H0. And the more the Bayes factor approaches 0, the stronger is the evidence for the null hypothesis rather than H1. So Harold Jeffreys proposed some conventional criteria, which is if your Bayes factor is greater than 3 or less than a third, we can count that as substantial evidence. Most criteria, I think, were well chosen because it turns out in hundreds of cases I've looked at, and this is roughly speaking, this isn't a mathematical result, it just turns out that if you get a significant result and the mean, this is the crucial thing, the effect size you obtained is roughly that you expected, then the Bayes factor will be about 3 or more. So traditional statistics and Bayes tend to agree when you get significant results. Unless you've done something funny like run until you got a significant result, then they come apart. But that means if we accept 3 as a good estimate of the sort of evidence that we as scientists have been used to using in rejecting the null and accepting H1, then by symmetry, less than a third is going to be the equivalent criterion for saying we have good evidence for the null hypothesis. So now we're in a position to make a three-way distinction, the three-way distinction we wanted to make. So if the Bayes factor is between 0 and a third, we have good evidence for H0. The Bayes factor is greater than 3, we have evidence for H1. And if it's in between, the data is insensitive. So what we need to know is what do our models, our hypotheses predict? For H0, that's easy. H0 is the hypothesis of typically no difference, no correlation, no relation, etc., at chance. It's saying there's a single population effect size that's plausible, and that's 0. But what we have to say is, well, what does our theory predict? We have to specify that. Is there a maximum plausible effect size, a minimum, a most likely one, and so on? Now, we should really have been doing that anyway, but because our stats allowed us to get away without doing that, we never quite got round to it. Now, it turns out there are some rules of thumbs you can use that make this process relatively quick. If you can think of a roughly expected effect size, a most likely effect size, roughly speaking, based on some other data, meta-analysis, or even other aspects of the same data, or maybe you can think of a maximum plausible effect, then that's fine. I'll skip over this quickly, just to give you an indication of, if you look at the bottom here, if you can think of a maximum effect you could expect in this situation, then the simplest and vaguest way of saying what does the theory allow, well, you could say it allows all effect sizes between 0 and that maximum as being roughly equally plausible or equally likely. The other thing you'd need to do for a Bayes factor, say in the case of a t-test, is to say what the data were, and it's just the same as you would do for a t-test. You need to say what was the difference between the conditions and what was the standard error of that difference. Well, the t-test is just the ratio of those two things, so you can easily get those two numbers. If you know your t-test from your conventional statistics, you know the mean difference, you can get the standard error, you now have everything you need to do a Bayes factor. It really is simple, by the way. Once you get your head around this, you could do them in 60 seconds. All right, so now let's apply this to conscious versus unconscious. So in an objective threshold, we want to say people are at chance at some classification test. Maybe some priming shows knowledge, but a forced choice test about what was there or something like that is at chance. I'll consider an example from implicit learning. Here's a serial reaction time task. People have, say, 4 buttons to press, and if a certain location or symbol comes up on the screen, you just press the corresponding button. It seems to the subject like it's just a reaction time test, you're just responding to what's there, but actually there's a sequence. For example, any 2 elements might completely determine the 3rd element, so there's a triplet structure to it. People get faster and faster. If you change the rule structure there, people suddenly get slower. If you reinstate the rule structure, they get faster again. Therefore, they have learned the sequence. But have is that knowledge conscious or unconscious? Well, what you might do is give them these triplets that constitute the structure and see how many of them are recognized. Now, let's say they're a chance at recognizing what triplets were part of the structure and which were not. Well, the typical thing to say is, look, the p-value was p equals 0.41. It's non-significant. Yes, the knowledge was unconscious. Well, you should know that that's completely illegitimate, and that conclusion doesn't follow at all. So I'll take an example from Shang et al., recent paper. From the reaction time data, there's a lot of reaction time data typically in serial reaction time tasks, you can see which triplets people have actually learned. So let's say out of 12 triplets that constitute the structure, you can say people have learned 5 of them. Well, from that information, you can work out what their recognition performance should be if they were perfect at recognition and consciously identified correctly each of those triplets that they knew. So based on that, what you could do is to say, well, recognition isn't normally perfect, so what we'll do is assume recognition performance could be anything from 0 up to that maximum value. That's the prediction of H1, and we can use that as a basis for a Bayes factor. So let's say recognition performance on a binary test, so chance is 50%, is 52%, with a standard error of 6%, is non-significant. But given the assumptions I've just given, the Bayes factor is between a third and 3. In other words, it's telling you this data is insensitive. You don't have grounds for saying that this was unconscious yet. This is not strong evidence for the null hypothesis. Well, I don't know what you think about this case. It's 52%, but now the standard error is less. Standard error has gone down to 2%. It's still non-significant, but the p-value is smaller, notice, in this case. So I don't know what your intuitions are, but I can tell you the Bayes factor is now a third, so you're now, just by conventional criteria, you do have good evidence for asserting the null hypothesis. And the reason why you do in this case is the standard error is smaller. You have more sensitivity in your data there. So just to go back here, notice the case where you had the smaller p-value, you actually had stronger evidence for the null hypothesis, as it turned out. It's not necessarily the case that the higher the p-value, the more evidence you got for the null. And that just goes to illustrate that point that I mentioned before. P-values do not distinguish insensitivity from good evidence for H0. You just can't use them for that purpose. The other thing I want to say about that, notice I did the Bayes factor on raw units. In other words, I found out what recognition accuracy should be. I didn't use a standardized effect size like Cohen's D. So if you go to Bayes, please don't use standardized effect sizes, because if you use standardized effect sizes, it tempts you to make your measure of conscious knowledge as insensitive as possible, so that the standardized effect size is as small as possible. It motivates you in exactly the wrong way. If you use raw units, if you make your test insensitive, the Bayes factor is going to tell you your test is insensitive. So you have to use raw units when you do Bayes factors. In the interest of time, I'm just going to I'll just say this very quickly. So you say, well, okay, how do I apply this in general? So let's say you've got a subliminal perception experiment. You've got a certain degree of priming. Classification is a chance. How do I know what H1 predicts? Well, what you need, and this fits in with something that Dave said, we need some other data, some basis for saying what level of conscious knowledge would we expect for that degree of priming. In other words, you need a condition in which we can say, I'm sure this was conscious. Now, even if you have minimal data, like just one data point of conscious priming, we can use that to estimate what your classification performance should be if the degree of priming we have in our nominally unconscious case was actually based on conscious perception. So just a little extra condition can easily get you what you need today to do the Bayes factor. So subjective measures, this was mentioned in the previous talks. Another basis for saying that knowledge is unconscious is people do not know that they know because there's no relationship between confidence and accuracy. Well, no relationship between confidence and accuracy, that's a null hypothesis. So how can we assert that? Well, there's different ways of measuring that relationship, and we can get at this in different ways. I'll just give you an example from D prime. If you use some sort of second-order D prime, type 2 D prime, or better would be meta D prime to express the relationship between confidence and accuracy, on a standard signal detection model, that can't be greater than type 1 D prime. So that automatically gives you a maximum value which you can use, and then you're away with your base factor. You have everything you need. This is just a little example from a paper. We flashed people instructions to either pick a word or not that word, and then they were given 2 words. They had to make a choice. We found that people could follow those instructions to some extent, even though we thought the words are being flashed subliminally. People gave confidence on the decisions after each decision. Type 1 D prime was above chance. Type 2 D prime was p equals 0.32. It looks like there's no relationship between confidence and accuracy. It looks like I can say, definitely this is unconscious. But actually, just based on what I said, using base factor with a uniform with type 1 as a maximum, it's not sensitive. We didn't yet have grounds to assert that the zero correlation criterion between confidence and accuracy was actually established. We could almost get there when we pulled over all the data in the experiment, but it's probably not quite as solid as one would want. So, take-home message, if you took anything home from what I said, is no inferential conclusions follow from a non-significant result in itself. But remember, probably every paper you read and every talk you go to will draw inferential conclusions from a non-significant result. So even though you all know that that's completely legitimate, it seems everyone nonetheless does it. So somehow it's in your bones to draw these conclusions which you know are wrong. And that's partly because you didn't have anything else to do. So it's now easy to use Bayes and distinguish evidence for the null hypothesis from insensitive data. And that, I think, puts objective and subjective thresholds now on a firm basis, because you now have a technique for saying, I have firm evidence for the null hypothesis. Okay, thank you. Questions? Yeah. Yes.
I thought that a couple of times you were in danger of falling into the same error that you accuse your opponents of, in saying that you get firm evidence for asserting the null hypothesis when the base factor is a certain way. I mean, I think what's true is that when the base factor goes that way, then you've got reason to raise your probability in the null hypothesis, say, by a factor of 3, but that will very often fall short of firm evidence for asserting it or for supporting it. It all depends on your prior probabilities. And I've actually always been impressed by the observation that the null hypothesis is almost always false, because the null hypothesis is an extremely precise hypothesis about precisely zero connection between these things. So precise that your priors in it should be extremely low, and getting a base factor of 3 is just going to multiply extremely low times 3. So likewise, in the case of unconscious perception, if you require precisely chance, maybe 0.500000, you've got very little reason for believing that, even upon getting a base factor of 3. So maybe there are ways to get around that by coarse-graining the null hypothesis, but I think one has to be very careful here.
Well, that's a good point, but let me just say one thing. I think the claim that the null hypothesis is never true is somewhat overstated. For example, there was a study with 35,000 subjects looking at ESP. Chance was 0.5, and the confidence interval at the end of that was, I can't remember exactly, it was something like 0.4999 to 0.5001. Or something like this. In other words, when you have a fully counterbalanced experiment that's well designed, the null hypothesis can be true to a very high degree of accuracy. Now, what you can do, and you can do in my own calculator, is instead of having a point null hypothesis, you could put in an interval null hypothesis. Now, if that interval is quite small, the base factor you get out, given the degree of uncertainty that we have in our experiments, is going to be almost exactly the same base factor as the point null hypothesis to a very high degree of precision. In other words, the point value is a really good model in many situations, because the Bayes factor you get out is going to be the same if you put in a realistic interval estimate of the null.
The point still remains is whether you have evidence for asserting it at the end of this is going to depend on your prior probabilities, which will depend on the size.
So what I've done is, in the Bayesian schema, you have your prior probabilities is multiplied by the Bayes factor to get the posterior probabilities. I sort of extracted the Bayes factor out of that context so that we don't have to worry about the priors. All we have to think about is, what does my data predict? What do my theories predict? Sorry. And so we have a measure of the relative strength of evidence for one theory rather than another. Now, you're right, I talked about asserting. This is just by conventional standards of strength of evidence. If you're dealing with theories that were highly unlikely, and I would argue contrary to what you're saying, I think the null hypothesis is normally, it can be sufficiently likely to a good enough degree of approximation that extracting the Bayes factor out of this full Bayesian schema is a perfectly legitimate thing to do. But let's say you were dealing with ESP or morphic resonance or some issue where people have wildly different prior expectations, then probably you want to put it back into the full Bayesian schema, as you say. Yep.
Thank you. You didn't refer to another problem, that the population is homogeneous or a single population. That's another problem, of course, that has come up in some of the experiments, but it also comes up in your last interpretation. When you have a population of 35,000 people, it certainly is not a homogeneous or single population. So then again, it looks very firm what you have, your P 0.499 or whatever, but it really can't be, because you can't have a homogeneous population of human beings of 35,000 people.
Yeah. I mean, we're not assuming a homogeneous population. All we're asking about is what does the population mean for whatever is the population that we've got. But you're right, it's always a good question. Are there meaningful individual differences in there? But then when you look at individual differences, you're probably going to use techniques of statistical inference. You're going to have null hypotheses. All the issues come up all over again. And then Bayes factors are going to be useful. But Bayes doesn't solve all the problems of design, obviously. Yeah.
So, yeah, this is working. So when I met Anil outside, he said, "Are you going off the rails with your title?" But hopefully you'll see what I mean by that. So one of the questions that David raised, a bit provocatively perhaps, is the question of knowing whether unconscious cognition exists. Obviously it exists. We have computers capable of carrying out sophisticated information processing in the absence of awareness, so there's no question that it exists. But the question is more like, to what extent does it exist? And if you look at the literature, particularly in social psychology, you have the impression that there's almost nothing left for consciousness. There's hundreds of studies that have come out recently. As David pointed out, there's a great surge of studies pointing out what we can do without awareness. And this goes on from, the fact that subliminal exposure to fast food logos makes you impatient. Incidental exposure to the smell of a cleaning fluid makes you more self-conscious of cleanliness when eating. Sitting in a hard chair makes you a better negotiator. Holding a warm versus a cold cup changes your impressions of someone you meet. And so on and so forth. And this is, picked up and amplified by the media in different ways. And if you look at different cognitive abilities, you have the impression that consciousness is this incredibly shrinking little bit, and that is really, just like the incredibly shrinking man, nothing much left for it to do. We can almost do anything without awareness. And so I think there's an interesting story to be told around the reason why this is happening now. I think there's an interesting narrative behind it. I think that we like the idea of not being in control. We like the idea that somehow the unconscious brain can process lots and lots of information, that we can be influenced by factors or stimuli that we do not perceive, and so on and so forth. So I think, you know, there's something that explains that in terms of what it does to people. So here's, for instance, one study that really pushed it far, I think, in terms of amplifying what we can do without awareness. And this was Dexter's study about decision-making that got published in Science a few years ago. And you remember that the situation involves people seeing the attributes of different objects, in this particular case, cars. So they see these attributes on the screen. One car is normatively defined as the best car because it has the most positive attributes. One car is the worst car. People see these attributes for a while, and then after that, they're told to either think about what the best car may be for 3 minutes, or to solve anagrams, basically. So to do a completely unrelated task during which they're distracted. And when they come out of this 3 minutes period of either doing anagrams or thinking about the problem really hard, they have to make a decision and tell you what their favorite or their best car is. And the results are as follows. There was a complex and a simple situation. In the simple situation, cars are defined by 4 attributes. In the complex situations, they were defined by 12 attributes. And when the decision was complex, that is, when each car was characterized by 12 different attributes, people who solved anagram for 3 minutes actually did better than people who thought about what the best car was for 3 minutes. So Dexter interpreted this and developed this in terms of unconscious thinking, which I think doesn't make any sense. But, you know, we have this unconscious thought theory according to which sophisticated information processing can take place in the absence of awareness, and according to which the unconscious has a larger capacity than consciousness, according to which the unconscious is more neutral, it is less biased than consciousness, and so on and so forth. So that's one interpretation of these findings, which we challenged in a series of replications that involved testing over 900 participants. It was a lot of work for the PhD student that was involved in this. But I'll just tell you about the results of the final study here, in which we ended up being able to replicate the basic effect. But we added some conditions. We manipulated the task that people do. Do they have to form an impression, or do they have to simply memorize the attributes? On the one hand, and then we also added conditions. In one condition, we asked people to make an immediate decision, so no anagrams, no thinking about it, just make an immediate decision. And then the other 2 conditions were as in the original study. And here's the results. In the classical, that is information impression condition, when people solve anagram for 3 minutes, they make a normatively better decision than when they're told to think about it. So that's the direct replication of Dexter-Hurst's findings. But what happens in the immediate condition? Well, as you see, the decision is just as good. Now, that is suggestive that there's no unconscious thinking going on in the unconscious condition when they solve anagrams. They're just solving anagrams, because they do just as well if they're asked to solve, come up with the decision right away. The reason why this is the case is that we also found out that most people make their decision during the exposure phase versus during this anagram or thinking phase. Yeah? So in fact, when they come out of the exposure phase, they have already made their decision. Yeah? If we now ask people to memorize the items, you can see that the decisions are worse, because now they have to compute something when they come out of the exposure phase about which combination of attributes corresponds to the best car. And when they're actually thinking about it, they actually make better decision than when they're not thinking about it. So the story here, it's the same data, but it's a completely different interpretation. In one case, you have this idea that, you know, the unconscious can think unconsciously and solve problems unconsciously. In the other case, well, we have this different interpretation according to which people already make the decision based on first impressions. And when the experimenter comes about and tells them, now think really hard about it, some of them actually change their decision for something else, yeah? For the worse, basically. So the moral is trust your first impressions, but it has nothing to do with unconscious thinking. And there's been a number of failures to replicate these findings recently. In fact, there's a solid stream of such failures to replicate findings from that part of the literature that is coming out most often in open access journals, I should point out. And so, you know, you don't really know what to think about this question. Does unconscious cognition exist anymore now when you see all these failures to replicate? And in fact, you have now what David characterized as proponents versus skeptics, I think, or believers versus skeptics. There's an email list where these issues are discussed. And there's a camp of people who believe unconscious cognition exists, and another camp of people who express skepticism about it. And this is reflected in the actors involved on each side of the debate. You have believers, I've put them over there. You have skeptics, I've put them over there. There's many other people. There's a pendulum that swings between these two positions. And right now, it's clearly on the side of the believers, even though there's a backlash by the skeptics. Those are the social cognition guys. And I'm sort of playing both sides of the fence here, appearing sometimes as a critic, sometimes as a supporter. I don't really know what to think about it anymore. One of the things that's clear, just as David pointed out, is that the unconscious, just like consciousness, is not a single thing. And in fact, if you look at these different fields and how it connects with you know, the characterization of the differences between conscious and unconscious processing, you can almost make a distinction between level and content, just as you can for consciousness, with different subfields depicting a completely different picture of the unconscious. We've written about this. There's a paper out that specifically tries to compare behavioral priming in the social and cognitive psychology literatures. You can look at that for a more detailed analysis of the differences, both in terms of methods, but also in terms of the characterization of the unconscious between social psychology and cognitive psychology. So there's a definitional challenge involved, just as for consciousness. Consciousness is not unitary. You can be aware of the presence or absence of a stimulus, or of your intentions or your actions, or of the fact that your behavior is influenced by a previous processing episode, and these are not necessarily the same thing. Likewise, different paradigms, either in different fields or in cognitive psychology, engage different aspects of consciousness. In subliminal perception or change detection, it's about awareness of the stimulus. In implicit memory, it's about awareness of the influence of a previous episode on current processing. In implicit learning, it's about awareness of the relationships between different stimuli. There's also a methodological challenge, which connects with what Zoltan described. And this amounts to solving the issue of finding out how to devise an appropriate measure of awareness. Most existing studies fall into what's been called a quantitative dissociation logic, where the idea is to compare the sensitivity of two different measures to some relevant information, a measure C of subject's awareness of the information, a direct measure, and a measure P of behavioral sensitivity to the same information. This could be priming, for instance. And then we conclude to unconscious processing whenever P exhibits sensitivity to some information in the absence of correlated sensitivity in C, with the statistical issues behind that that were described by Zoltan. There's many issues with this logic. There's an immediacy problem. Typically, you can't obtain both measures simultaneously, and I'll get to that again later. There's a relevance problem. You have to make sure that whatever you ask people about in the awareness test is actually relevant to their performing the main test that exhibits behavioral sensitivity. There's a sensitivity problem. You want to find out ways of ensuring that your test of awareness is as sensitive as your test as your behavioral measure. Otherwise, they're not comparable. And there's also a selective influence problem, that is, this logic assumes that task performance is driven by unconscious contents in these sorts of designs, and that your measure of awareness is measuring exclusively conscious content, and that it's also exhaustive, that it's measuring all of a person's conscious representations. All of these assumptions are problematic, in particular the last one, because you can very well imagine that even objective tests of awareness are influenced by unconscious contents. And likewise, performance in a task will always involve some degree of awareness also. So this assumption of task purity, or that tasks are process pure in general, is wrong, yet many designs fail to acknowledge it. Of course, there's alternatives, of which one spoke quite a bit a few years ago, and perhaps a bit less so now, such as Miracle and Rengol's relative sensitivity approach, or Jacobi's process dissociation procedure, that get around this selective influence or process purity assumption. But I won't have the time to get into that. So here is the basic design of many such tasks in this domain. You have an exposure, training phase, an indirect task, which can be a priming task, an artificial grammar learning task, a memory task of some kind. And then later, at some further point in time, you have an awareness test or a direct task in which you ask people to make the relevant discrimination, but this time consciously. And this can involve an objective test or a subjective test. It could be identification or an alternative force choice task. If it's an objective measure, it could be a subjective measure, such as collecting a verbal report. In social psychology studies, typically it would be a funnel debriefing, where increasingly detailed questions are asked of participants about their awareness of, say, the relationships between certain stimuli and their behavior. It could be a confidence rating, and so on and so forth. In all such cases, we have to remember that none of these tests are pure with respect to the processes that they involve. Any of these tests, be it the direct task or the indirect task, can involve both conscious and unconscious influences. Newell and Shanks have come up with a very critical paper recently in BBS, in which they remind us of the criteria that any test of awareness should fulfill. They list 4 of them. I won't go through all of them, but illustrate some of them as I go on. One is reliability. Of course, you want your measure of awareness to be reliable, not to be too sensitive to task demands and to social desirability effects, which is the case in many situations, despite, again, the fact that many people simply ignore that. The test should be relevant. That is, it should concern the same information as involved in the indirect task or the behavioral task. The test should be as immediate as possible to avoid forgetting effects. So typically, one would like designs in which the awareness measure is collected on a trial-by-trial basis with the performance measure, and the task should be sensitive. All of these criteria can be problematic. So, for instance, in artificial grammar learning, the early studies, which involve presenting people with letter strings like this, all the letter strings are generated based on a finite state grammar. Then people are asked to judge later on in the second phase of the experiment which of new strings respect the rules of the grammar or not. Typically, one would ask people, can you verbalize any of the rules of the grammar? But many experiments later showed that this was a completely irrelevant question, because the task can be performed in the absence of knowledge of the rules of the grammar. It can be performed, for instance, on surface characteristics of the material. Another issue in all these tasks is that, or all these designs, is that awareness cannot be turned off. People are always trying to figure out what you want from them in any of these situations, and despite your best efforts to make the information visible or unavailable to awareness. There's basically 3 strategies that you can use in order to induce unawareness. You can weaken the stimulus, which is a method typically used in cognitive psychology by degrading the strength of the stimulus. You can divert attention, and this is much more typical of social psychology. Or you can change the narrative by using methods such as suggestion or placebo. I won't get into that at all. Weakening methods involve all the methods that have been described this morning: backward masking, meta-contrast masking, continuous flash suppression, coding, and so on and so forth. The details matter in all these tasks, and I'll get to that in a few minutes. For all these methods, weakening methods, there's a strength-efficacy dilemma. If you weaken the stimulus too much, you have no effect. You have no priming, for instance. But if you let it be stronger, then you have awareness. That is, it's very difficult, in general, to find the right spot between the subjective and objective criteria. Here's the objective threshold, sensitivity. Here is the subjective threshold. You want to be somewhere there, but there's a real dilemma in designing the material so that you fall between these two extremes. The other strategy is misdirection, so attentional manipulations. This is the case in attentional blindness, the attentional blink, change blindness, loading working memory, and so on and so forth. The trouble there is the observer paradox. The more you probe awareness, the more you attract people's attention to the very thing they're supposed to remain unaware of, which prevents you from using trial-by-trial designs when you're manipulating attention. Here's a good example of the observer paradox. The study by Damasio involving the Iowa gambling task. People select a card from one of these decks. Over time, they learn which decks are good. They're asked to verbalize the basis of their decision. What Damasio showed is that behavioral sensitivity, that is people's ability to select the good decks, precedes their ability to verbalize the reasons for selecting those decks. Later on, Maya and McClelland replicated this study and used a different probing method that involved asking more precise questions at many more points in time during learning. And as you can see, you switch from a pattern of dissociation between performance and reportability to a pattern of association. That's exactly the observer paradox. The more you ask people, the more aware they become. Even objective measures can be problematic. We carried out a series of studies recently looking at D prime, for instance. So D prime is the gold standard. D prime is D prime is D prime. You know, it's the best measure. Here we looked at what happens in a priming situation that involved Warburg-type stimuli, where people see masked arrows pointing to the left or to the right. They have to respond to a target, which is also the mask, which is also pointing to the left or to the right. The prime can be congruent with the target or not. The target acts as a meta-contrast mask for the prime. And so we use a psychophysical design with 4 conditions to assess visibility after the priming task: a standard D prime task, a neutral target task, in which the target, the arrow, was replaced by this figure, which doesn't contain any direction, a switch test occurring all the way through the priming task. So when the target was neutral, people's instruction was to respond to the prime as opposed to respond to the target. And we also compared conditions where after the trial, people had a delay of 800 milliseconds versus an immediate response before producing their response. We get priming results that are not very interesting. What's interesting here is to see what happens to D prime under these different conditions. And the only point I want to make is that a lot happens with D prime according to these different manipulations. So we get higher D primes, for instance, when there is a delay. But it's a detail, yeah? It's just a short delay, but it has a strong influence on D prime. Okay, I'm running out of time. I'm going to go through this to illustrate what happens with subjective measures. You all know the PASS scale, perceptual awareness scale. That is a subjective scale that involves 4 steps. In a study involving blindsight, we compared what happens when we use the patient to judge visibility using PASS versus when we use binary judgments, that is seen, not seen judgments. So this is the visual field of the patient. When we use seen, not seen judgments in a discrimination task that involves shapes presented in the blind field versus in the visible field, we get blindsight that is better than chance performance in the blind field and no relationship with the visibility judgments in that blind field. When we use PASS with the same patient, though, we get exactly the same relationship between accuracy and visibility in both the blind field and the sighted field. This is a completely different conclusion, just as with the Dijksterhuis study. In one case, we conclude unconscious vision. In this case, we conclude conscious but severely degraded vision, just as a function of the scale that we use. Here is another example. Do I still have 3 minutes? Oh, okay. Here's another example involving, again, a simple perceptual situation. We present different shapes to people. The shapes are masked. On each trial, people have to identify the shape, and they have to judge the visibility of the shape using one of 3 different scales, either PASS, confidence ratings, or post-decision wagering. All scales involved 4 different points. And here is what we find. It's again a psychophysical design. You have the 3 different scales here, PASS, confidence ratings, post-decision wagering, the stimulus duration here, and the 4 different points of each scale at the bottom here. If you look at what happens with post-decision wagering, where people place a bet on their decision, you can see that we have a very sharp transition as a function of duration. So people bet very low amounts of money up until they get to this middle range here, and then they abruptly switch to betting large amounts of money. That pattern, which would suggest that consciousness is all or none, is completely different from what we get with PASS, which has this much more graded relationship between duration and visibility. People use the intermediate ratings here in a way that they don't when using post-decision wagering. Here's another study that was recently completed that leads exactly the same results, but in a different domain, so I'll skip that. We've also looked at graded scales in themselves. We compared a scale involving 21 points to a scale involving 7 points. You might think that performance would be more graded with the more graded scale, but in fact, in this particular situation, we find the reverse. That is, people tend to use more of the extremes of the scales when the scale involves 21 points versus 7 points. So it's a highly counterintuitive finding in this particular case. So the moral of all this is that the observed relationship between performance and awareness truly depends on your measures of each. The details matter, even for objective tasks that are thought to be immune to methodological subtleties like D prime, and different measures give completely different results as a function of their nature. So it's very hard to demonstrate causal efficacy in the absence of awareness. Many of these social psychology situations, but also cognitive psychology situations, I think, are highly debatable, and this debate is ongoing right now. There's the strength efficacy dilemma, the observer paradox, the reported effects are generally small and fleeting, the details matter, and the methods matter. On the other hand, and I haven't talked about this, but I thought it was important to combat the shrinking man or incredibly shrinking man impression one has looking at the literature now. The effects of consciousness are huge. If you think of the placebo effect, 30%, it's huge. There's a strong distinction, particularly in terms of social psychology versus cognitive psychology, between unconscious processing and pre-conscious processing. Maybe we can get to that in the discussion. So parting thoughts, replicate. I think this is really crucial. Manipulate expectancy effects, contrast different methods, different scales, and systematically compare conscious versus unconscious processing. That's it. Thank you.
This is for the last speaker. So I've been racking my conscious mind through your whole talk to figure out the connection between the title and the rest of the talk, and I didn't get it, so I just wondered if you could explain what the sea serpent of the mind was.
The sea serpent.
Yeah.
Do you have a microphone? You might want to hold it in your hand.
Right. The sea serpent was, meant to characterize the fact that if you look at this literature, it seems to oscillate between, this idea that we can do a lot without awareness seems to come back and then to be fought back again by critics, and then to come back again in a different way. So that seems to be the story of this entire field for me. Think of the critique of the entire subliminal perception literature by Hollander in '86, and then the rekindling of that same literature by Stan DeHaan in 1998, and then, all the burgeoning social psychology literature with these more or less unbelievable effects, which is now again eliciting a backlash from the skeptics of this literature. So that's the sea serpent.
Any other questions?
There was a question?
Thank you very much for the really interesting talks. I'm really interested in what do you mean when you talk about unconscious processing? It seems like there's a huge difference between researchers and groups in what they mean by that. For example, Dr. Claremans, you talked about it as computers have unconscious processing because they have information processing. And then I think other people might think that there's almost something like another person inside your brain doing the unconscious processing. So where on that scale do you all fall?
So I'll start, maybe the others will chime in. So I think starting off with the fact that, computers can do all kinds of stuff, and yet we don't attribute consciousness to them is a good starting point. We do attribute consciousness to most human beings, but we also have this notion that not everything that can be accomplished by human beings necessarily is accompanied by consciousness. I personally believe, and I don't use this word in a faith-based context, but based on the evidence, that some of the operations that are performed by the human brain are performed without any active involvement of the processes that underlie our awareness of this processing. I think that's the kind of thinking that underlies a great deal of work in recent years. And the main issue is that we haven't quite defined as a field what we require in order to claim that we have indeed found this. I think there's cumulative evidence showing that the idea itself is tenable, but I think there's also a lot of problematic evidence out there, and we need to figure out ways to make it more robust. If anyone wants to add anything.
I'd like to start from theories. So two of the main theories out there are higher-order theories of different types, and then global workspace integrated information theories of various types. And from a higher-order perspective, some mental state would be unconscious if you were not aware of being in that mental state. So it's sort of metacognitive, or it's a metacognitive matter in terms of having mental states about mental states. So that motivates a certain methodology, but that same methodology, I think, is motivated by global workspace theories, because if information is in the global workspace, it's available to higher-order thought boxes, and so it would be available to, if you probed about, if you're aware of the knowledge, you would be aware of the knowledge. So two of the main theories out there motivate subjective measures, and so in my own work, I use subjective measures, and for me, unconscious mental states a person is in because you can show that by the performance, but they're not aware of being in it when you PAS, confidence, or some other measure like that.